Welcome to this channel, Math Study Tutorials. Today we are going to be looking at quadratics, the first video. So this video is mainly on the basis of expressing a quadratic function in terms of a perfect square, as well as determining the vertex of a quadratic function. So first of all, I'm going to highlight the steps that we need to take to express a quadratic function in the completed square form. So first of all, the quadratic expression, the quadratic function, is of the form ax squared plus bx plus c. And if you notice, the highest power of x in the function is 2. That's what makes it a quadratic function. So what we're doing basically here is explaining. What I'm doing basically here is explaining the steps, the ways that helps you arrive, that helps you express the term, the expression in terms of a perfect square. So we are considering this expression right here. We are considering this expression right here. X plus a all squared. That's a perfect square. And this a right here is a constant. It could be 1, it could be 2, it could be 3, it could be any whole number. It's a constant. So that's a perfect square. And that is how we want to express our quadratic function, even if it may not be a perfect square. You get that? So on expansion of this perfect square, not a perfect square, it just has a perfect square root. So on expansion of this perfect square, you have x plus a all squared. So if you have x plus a all squared, just like 3 squared is the same thing as 3 times 3. That's the same way we now do x plus a times x plus a. That's x plus a bracket x plus a. So the first thing we do is to multiply this. That's x times x plus a and a times x plus a. So x times x is going to give us x squared as we have here. Then x times a is going to give us ax as we have here. Then this a times this x gives us ax, right? And a times a is going to give us a squared. And ax are like, right? They're like terms, so we have the right to add them. Ax plus ax is going to give us 2ax, as we have written down here. So what do we notice? And how does this help us in expressing a term, the expression in terms of a perfect square? We look at the terms. This term bears x squared. The term bears x squared. And then we have 2ax, right? And then we have a squared. So what do we notice? The coefficient of x in this expression is 2a. And we notice that half of this coefficient is a. And when we square that coefficient, is equal to the constant term, which is a squared. A squared, right? So that is the main thing here. So how does that help us? I want us to see a graph before we continue. And it's a graph of, this is a graph of x plus 3. This is a graph of x plus 3 all squared, right? This is a perfect square. Graphs of perfect square just look like this. They have their vertexes. They have their maximum or minimum points touching the x-axis, touching the x-axis at only one point. Now let's plot another one. If we plot the graph of y equal to x negative 5 all squared, let's do that. X negative 5 all squared. Let's see what we have at the end. So on plotting, this is what we have. You see, on one point it has just one solution. It has one solution twice. That's why when we solve equations like that, we have one solution twice. So now let's go back to what we have. And not to forget the main stuff here. Half the coefficient of x in the expression, then squaring it. So let's start with question number 1. What we have here is consider your expression x squared plus 4x plus 7. So the first question is, the first thing we ask ourselves is, what must be added to x squared plus 4x. We're not going to consider the constant term. In this case, the constant term is 7. For now, we're not going to consider it. So, first question is what must be added to x squared plus 4x to make it a perfect square. So all we have to do is to half the coefficient of x, and in this question, the coefficient of x is 4, so half of 4 is 2, and 2 squared is going to give us 4. That means 4 should be added to x squared plus 4x to give a perfect square. That means we now have x squared plus 4x plus 4. So if you have x squared plus 4x plus 4 as a perfect square, it could be factorized as x plus 2 squared. You could use factorization method to factor this. That is basically two numbers you add that will give you 4x, and you multiply, that will give you 4x squared, and that's basically 2x and 2x. 2x plus 2x is 4x, and 2x times 2x is 4x squared. That's the basic thing here. So if it's like that, we now have x plus 2 all squared on factorization. Or if you don't want to do it like that, just take what's half the coefficient of x. Half the coefficient of x, that's half of 4 is 2, and that's the determinant of what is here, x plus 2 all squared. So if you have x squared plus 4x plus 4 as x plus 2 squared, we now need extra 3 because we have to maintain this expression that says x squared plus 4x plus 7. Since x squared plus 4x plus 4 is a perfect square, we now need extra 3. That will now make it x squared plus 4x plus 7. So you're now going to group the x squared plus 4x plus 4 as a perfect square. You get that? And then write it as x plus 2 squared plus 3. Please, before we continue, ensure you have subscribed, liked, and shared this video. Do well to do that. For question number 2, we are given the expression 3x squared negative 12x plus 7. Quite different from the first one. So what we simply do here is to factor what we have. Remember I said, let's now focus on this part now. So I'm going to take 3x squared in negative 12x, and we're like, what must be added to 3x squared negative 12x to give a perfect square? So I'm going to factor it. We can see that 3 is a factor of 3x squared and is also a factor of negative 12x. So all we need to do is to bring out the 3, and then we divide. 3x squared divided by 3 is going to give us x squared, which we place in this bracket. Then negative 12x divided by negative 4x is going to give us negative 12x divided by 3 is going to give us negative 4x, which is placed in this bracket. Do you get that? And then plus 7. But the next question we have to ask is, what must be added? Remember, our goal is to express it in terms of a completed square form, right? So we look inside the bracket. Inside the bracket, you have x squared negative 4x. And then we ask, what must be added to x squared negative 4x to give a perfect square? And what is that? Half of the coefficient of x. Half of the coefficient of x in this case is negative 2. So negative 2 all squared is going to give us a positive 4. Right? It's going to give us a positive 4 because negative times negative is going to give us a positive. And 2 squared is going to give us a positive 4. So we have a positive 4. So if we include 4 in that bracket, that means it's now going to become a perfect square, right? To see where 4 is included, right? 4 is included. But if 4 is included, there's actually going to be a change. If you're now expanding this stuff, 3 times x squared is going to give us 3x squared. 3 times negative 4 is going to give us negative 12x. And 3 times 4 is going to give us 12. But what was given to us? 7. So we have to add a negative 5. We have to subtract 5. Because 12 negative 5 is going to give us that 7 that was initially here, retaining the same expression. Our aim is just reforming it, right? So this is 3 times 4, 12. If you expand this, we now need minus 7 to now make it what? Plus 7. That's what is here. So 3 bracket x negative 2 all squared negative 5. 3 x negative 2 squared negative 5. That's plus 4. And then opening it, you have to, then negative 5 now give you a plus 7. Then for question number 3, you could attempt it yourself. You could pause this video and then test yourself based on the knowledge you've gotten from questions number 1 and questions number 2. So to solve the expression, and we are required to express that stuff, x squared plus 6x plus 2. That's question 1.3. X squared plus 6x plus 2 as a perfect square. So the first question is, remember I said do not look at the content and constant term for now, but it's important. So the first question is, what must be added to x squared plus 6x to give a perfect square? And what is that? You look at the coefficient of x. What is the coefficient of x? 6, right? Then half of 6 is going to give us 3. And 3 squared is going to give us 9. So 9 must be added to x squared plus 6x to give a perfect square. And that's likely to be x plus 3 all squared. Because half of 6 is 3. Using factorization, you can also get that. Two numbers you add, that will give you 6x is 3x and 3x. Is multiply, that will give you 9x squared is 9 is 3x and 3x. Nice. So if you have x squared plus, if 9 should be added, that means you're going to have x squared plus 6x plus 9 as what? X plus 3 squared. But remember, we have to retain this constant term. So we have to subtract 7. 9 negative 7 is going to give us what? Plus 2. So we're going to write it as what? X plus 3 all squared. This x plus 3 squared is the same thing as what? X squared plus 6x plus 9, then minus 7. X squared plus 6x plus 9 minus 7 is going to give us what? X squared plus 6x plus 2. You get it? Which is the expression that has been given to us. Retaining that. So this is the answer. X plus 3 squared negative 7. That means we have expressed this function, this x squared plus 6x plus 2, in terms of a completed square form. Nice. Now, if we should sketch the graph, I want us to look at the graph of this. That's the graph of x squared plus 6x. Let me change this to the graph of x squared plus 6x plus 2. X squared plus 6x plus 2. And let's see how it looks like. So it's the red one. It's the red one in this case. So this is the graph of x squared plus 6x plus 2. And now look at it. Remember, we sketch graph. This is a perfect square graph. But this is the curve that has been given to us, x squared plus 6x plus 2. And at the end of the day, when we expressed it as a completed square form, what did we have? X plus 3 squared negative 7. That means it's not a perfect square, but it has been expressed in terms of a perfect square. So looking at this graph, imagine if this expression is a perfect square. That means it was actually on this spot, on the x-axis, but it now steps down. That's what the equation is telling us. X plus 3 squared, then negative 7. That's a vertical translation by minus 7 units. And if you look carefully at the screen, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. It now went down by, that means if it was initially here, when you go down by 7 units, you're going to get the curve, which is x squared plus 6x plus 2, which is what was given to us. I hope you understand. Please do not forget, if you've not subscribed, do well to subscribe, like, and share this video. So let's continue. We have past papers that I sourced out. Question number 1. Express 2x squared negative 12x plus 7 in the form a bracket x plus b all squared plus c, where a, b, and c are constants. Very easy. All we have to do is to look at the expression. Remember, I say do not consider the constant term for now. In this case, the constant term is 7, right? So we now factor. We look at this stuff. This is 2x squared, right? This is negative 12x. So we factor it out. Look at the form that we're given. A bracket x plus b. That means we're expressing it in terms of a perfect square. So we bring out 2, right? We bring out 2. 2 can go into 2x squared. 2 can go into negative 12x. So if 2 goes into 2, we're going to have 2x squared, we're going to have x squared, and if 2 goes into negative 12x, we're going to have negative 6x. So we now have 2 brackets x squared negative 6x. That's like a form of factorization. Then the next question is, what must be added to x squared negative 6x to give a perfect square? And it's just simply half of negative 6. And half of negative 6 is going to give us a negative 3. And what's next? We square it. Negative 3 squared is going to give us a positive 9. As I said earlier, 3 squared is 9. Negative times a negative is going to end up as a positive. That means we have to add 9 to give a perfect square. So if we include 9 in this bracket, remember we initially had x squared negative 6x, But if 9 plus 9 is included in this bracket, what happens next? That means we now have 2x squared negative 6x plus 18, negative 12x, sorry, plus 18, which is not what we are given. We are given 2x squared negative 12x plus 7. So to retain the expression we're given, we would have to do what? Subtract what? 11. We would have to subtract 11 to retain the plus 7. Why? Because 18 negative 11 is going to give us plus 7, which is what is given. So we'll not write it as 2 bracket x negative 3 all squared, because when you factorize x squared negative 6x plus 9, right, we're going to have x negative 3 all squared. Then you add your what? Negative 11, because by the time you expand all this, that's this alone, you're going to get this, that is 2x squared negative 12x plus 18, and then negative 11. When I minus 11, 18 negative 11 is going to give you the plus 7. I hope you get that. Nice. So question number 2, you could attempt it. You could pause the video. This is the question. F of x equal to x squared negative 4x plus 8 for all real x. And the question says, express f of x in the form of x negative a all squared plus b, where a and b are constants. That's what they're asking us. So they want us to express in terms of a perfect square. You can pause the video and attempt from all you have learned and do this on your own, and then cross-check whether your answer is correct or not. So what do? We look at x squared negative 4x plus 8. And what do we do next? X squared negative 4x, we now ask ourselves, what must be added to x squared negative 4x to give a perfect square? And what is that? Simply half of negative 4. What is half of negative 4? It's a negative 2. Right? It's a negative 2. And then we're going to square it, right? According to what that's happened in introduction. So negative 2 squared is going to give us a positive 4. So that means we need to add 4 to give a perfect square. That's x squared negative 4x plus 4. But the expression we have as f of x is giving us x squared negative 4x plus 8. So we need another positive 4. There's a 4 here. So we need another positive 4, because 4 plus 4 is going to give us what? 8, right? So we need another positive 4. So since extra 4 is needed to maintain f of x, we have to add 4. This x negative 2 all squared is equals what? X squared negative 4x plus 4. Then plus another 4. That will now give us what? 8. Remember how I told you to do it? It's either you use the factorization method. 2 numbers you add, that will give you negative 2x, right? Negative 4x, and that's negative 2x, negative 2x. And you multiply, that will give you what? 4x, and that's still negative 2x, negative 2x. So we can factorize, and at the end of the day, you will have x negative 2 squared, or you just take whatever you have at the end of halving the coefficient of x. Half of negative 4 is what? Negative 2. And I think that's what that should be the determinant of what's in here. That's negative 2, x negative 2 all squared. It has worked all the examples we've done. So question number 3, could also pause the video and attempt it. It says express g of x equal to 16x squared negative 24x plus 10 in the form 4x plus a all squared plus b. This is another style of how the questions go. And it's still connected to the completing the squared method, but the approach will be quite different, because in this case, we are not having all the other ones we'll be doing. Look at this. The coefficient of x in the bracket doesn't bear any coefficient, right? But this bears a coefficient. It was not even that they said 4 bracket x plus a all squared. Then I wrote 4x plus a all squared. So it will be a little bit stressful to go through the completing square method. So the best thing to do is to compare the two expressions to what is given to you. Remember, they said express g of x equal to 16x squared negative 24x plus 10 in the form. That means it's the same. So if you have f of x, I now the way I did it, the way I solved it, I said let f of x be equal to 4x plus a all squared plus b. Then what did I do next? I expanded the expression. And now, what do? I now compare it with this and get these variables that we're looking for, a and b. Because they say we should express it in this form. That's what the question says. So, 4x plus a all squared plus b. First of all, we'll handle this portion, 4x plus a all squared, which is equivalent to 4x plus a times 4x plus a. So if you take this 4x and multiply by this entire expression, 4x plus a as seen here, plus a times this entire expression, 4x plus a. 4x times the 4x is going to give us 16x squared. 4x times a is going to give us a 4ax, and 4x times a is going to give us 4ax, and a times a is going to give us a positive a squared. So that means we could say f of x is equal to 16x squared plus 8ax, because 4 plus 4 is going to give us an 8. 8ax plus a squared plus b. Note that a and b are constants. So we move on. So we compare it with our earlier expression. Our earlier expression was 16x squared negative 24x plus 10. So if we compare them, 16x squared matches to 16x squared, then 8ax matches to negative 24x, and then a squared plus b are likely to match to the constant, which is in this case, the constant is a plus 10. So if we match 8ax to be equal to negative 24x, 24ax due to the comparison, you see the comparison on the screen, 16x squared to 16x squared, 8ax to negative 24x. So if you have 8ax equal to negative 24x, this x could take off this. That means you could take off this x and strike this x off, right? Strike the x off, and we just have 8a equals to negative 24. So how do we get a? We divide both sides by 8. That's the coefficient of a to get what a actually is. So if we divide 8a by 8, we just have a. And if we divide negative 24 by 8, we're going to have a negative 3. Right? We're going to have a negative 3. So we could go back and substitute. So if in this expression we had a, we have gotten a as negative 3 now due to the comparison. So we could actually say that this is what? 4x negative 3 squared. We have not gotten b yet. So calm down. So that means we have what? 9. Negative 3 squared, because at the end point we have 16x squared. Please pay attention. 16x squared plus 8ax plus a squared. So we have gotten a as minus 3, and now we have a squared, isn't it? So negative 3 squared is going to give us in positive 9, right? So if we now have that, we now have 4x negative 3 all squared is equal to 16x squared negative 24x plus 9, right? That is the expression we have. 4x negative 3 squared as seen, and 16x squared negative, because if you put a here as negative, we have negative 24x, and then plus negative 3 squared is going to give us a positive 9, which is what we have here. But the earlier expression we're given was what? A positive 10. The constant was positive 10. The question was f of g of x equal to, if you look, g of x was equal to 16x squared negative 24x plus 10. But we have 16x squared negative 24x plus 9. So we need extra 1. Remember I said you must maintain the expression that's given in the question. So we need extra 1. So we could write it as what? 4x negative 3 all squared plus 1. On expansion of this, we're going to get this. We're going to get this. 16x squared negative 24x plus 9. We're going to get that. Then we now need 1, right? That will now give us 16x squared negative 24x plus 10. Remember, this method could also be useful to the others. But it depends. It's best to use it in this kind of question. It's best to use it in this kind of question. So, the next thing we're going to look at now is the determination of vertex. First of all, what is vertex? The vertex of a parabolic quadratic function is just basically the maximum or the minimum point, or we could say the highest point or the lowest point on the curve. Now I'm going to illustrate it with a diagram as seen as this graph. So look carefully on your screen and look at where my pointer is. At this point, this minimum point, well, that's where the curve has its lowest point. That is the vertex. Here, where the curve has its lowest point, that's the vertex. Remember, I say it could be the maximum point, it could be the minimum point. Now, I want to show you the case where we have a maximum point. So let's say the graph of y equal to negative x squared plus 5x positive 6. And now if you look at the graph, we have this. I said it could be maximum or the minimum. So this point, that maximum point, that highest point, is the vertex. It's a point. It's a coordinate. So how do we determine it? It's totally connected to what you have been learning from the beginning part of this video. What is that? How do we express it in the completed square form? Please, I remind you again, do not forget to subscribe, like, share. Subscribe to this channel, like and share this video. Turn on the notification button on for this channel. So how do we have been doing? We have been expressing quadratic functions in terms of the completed square form, right? So let's see how we can apply it in determining the vertex of the function. As I said, it's the highest point or the lowest point on the function. So question number 1 says, by expressing negative 2x squared plus 8x plus 11 in the form negative a bracket x negative b all squared plus c, where a, b, and c are positive integers, find the coordinates of the vertex of the graph with equation y equal to negative 2x squared plus 8x plus 11. Remember, look at the question, negative a. So that means you're going to bring out a negative factor here. So negative a, remember a, b, c are constants. So what do? Look at the expression. We notice that negative 2 can go into negative 2x squared and can also go into positive 8x. Remember, we are looking at those that carry the x. We are not considering the constant term, which is 11 in this case. So if you factor it out, if you bring out negative 2, which is common to negative 2 and 8. If you bring out negative 2 divided by negative 2x squared is going to give us a positive x squared we have in the bracket. Then 8x divided by negative 2 is going to give us a negative 4x, right? So we have x squared negative 4x, and remember we still have our plus 11. So next question is, what must be added to x squared negative 4x to give a perfect square? What is that? I have been saying this from the beginning part of this video. It's simply half of the coefficient of x in that expression and then squaring that and that value. So half of the coefficient of x here in this bracket, because that's where the perfect square is going to come out from. So half of negative 4 is going to give us a negative 2. And negative 2 all squared is going to give us a positive 4. Right? So if you now include 4 in the bracket, it's going to be like a change. Right? It's going to be a change. So it's going to be a change. So if you include a positive 4 in this bracket and negative 2 times a positive 4, and negative 2 times a positive 4, remember that negative times a positive is a negative. So negative 2 times positive 4 is going to give us negative 8. So if you have negative 8, we look back at the expression we have been given and ask, what must be added to retain this 11? Remember, as 11 we have. When we added 4, which was needed to give a perfect square, that's negative 2x squared plus 8x negative 8. What must now be added to retain this 11? We need a positive 19, because negative 8 plus 19 is going to be 11. Negative 8 plus 19 is the same thing as 19 negative 8. 19 negative 8 is going to give us a plus 11. So negative 2 bracket x negative 2 all squared plus 19. Right? plus 19. Y equals to negative 2 x negative 2 squared plus 19. So how do we use that to get the vertex? Now, before I explain on how the vertex was gotten, I want us to see the graph of the function. The graph of negative 2x squared plus 8x plus 11. So let's look at it. Graph of negative 2x squared. I think I need to clear this. Let me clear this. Oh, why did I clear that? So y equal to negative 2x squared. I want you to see how the graph looks like. Negative 2x squared plus 8x plus 11. Right? So if you have this, it's the red graph, please. Looks like I have to remove this other two. Let me remove this other two so that what we're looking at is going to be clear. Clear as crystal. Graph of negative 2x squared plus 8x plus 11 is shown. So this is it. So let me explain getting the vertex and then we come back to the graph. So now, this is what we have. So basically, determining the vertex, just understand first, I've been explaining how to write in the computed square form. Once you get that, getting the vertex is going to be no issue. So all you have to do is to look at this expression. The part carrying the x, that's the square part, x negative 2 squared. So the first thing we do is to equate that square part to 0. Because remember how the graphs of perfect squares look like. They are going to touch the x-axis at only one point. At only one point, right? And how is that gotten? And how do we know what point they actually touched? Did they touch x equal to 1, x equal to 2, x equal to 3, stuff like that? How do we know? So, all we need to do is to equate that part to 0, right? Because the origin started from that point. So we equate it to 0 because we are equating it to the line of y equal to 0. The line y equal to 0 is equivalent to the x-axis. So x negative 2 squared equal to 0. If you find the square root of both sides, square root of 0 is what? 0. Square root of x negative 2 all squared is what? X negative 2. So we equate x negative 2 to 0. So when this negative 2 crosses to the right hand side of the equation, it's gonna cross to be a positive 2. So the vertex of that quadratic function is 2. At that's the value of x at that point of that vertex. Then how do we get the y value? Remember, the vertex is a coordinate. And that's x comma y. So the y is determined by this. The positive 19 at the end is what tells us what the y is. Because if we look at this graph, let's look at the graph. Look at the graph closely. Right? If you start from this point, that's the origin. I'm at the origin right now. I move one step, that's 1, and that's 2. Right? It's 2. Then we trace it up. And if we count, this from here, we have 10, we have 11, we have 12, we have 13, we have 14, right? We have 15, we have 16, we have 17, we have 18, and we have 19. So if it was actually a perfect square, it would just be resting. One point of the curve would just be resting on this x-axis. But what happened? The curve now stepped up by what? 19 units, right? And that is why it now landed here. There was a transformation from a completed, that's a perfect square graph. So that's a positive 19. Right, that's a positive 19. So we need a positive 19, and that's what tells us what the y value is. Because the x value remains constant. If it lies on the x-axis, the x value remains constant. If it steps up, it still remains. It's just the y value that's going to change because there is a vertical translation and stuff like that. So our vertex is 2, 19. You can pause the video and attempt the second question on determination of the coordinates of vertex. Question number 2 says, the function f is defined, sorry for the typo there. is defined for all real x by f of x equal to x squared plus 8x plus 9. Now the question is, by using completing the square method, find the coordinate of the vertex of the curve y equal to f of x. It's still the same old thing we've been doing from the beginning part of this video. We do not consider the constant term for now. We look at these ones that have possessed the x values. That's x squared plus 8x. And we ask, what must be added to x squared plus 8x to give a perfect square? And that's simply half of the coefficient of x. Half the coefficient of x in this case is 8. Half of 8 is 4. Then remember, don't forget to square it. 4 squared is what? 16. So that means x squared plus 8x plus 16 is a perfect square, right? But remember, we have to retain f of x. If we have a positive 16, that means we have to get a negative 7. Because 16 negative 7, that's 16 minus 7 is going to give us a positive 9, right? It's going to retain this. So we're going to have x squared plus 8x plus 16 minus 7, which is still x squared plus 8x plus 9. So we are now going to write it as x plus 4 squared. Remember how we got this. Please do not forget. Could either be by half of x is a positive 4, then we have a positive 4 here, or use factorization method to factor x squared plus 8x plus 16, and you have this. Then you add your negative 7, because 16 negative 7 is going to give us a positive 9. Now what is the vertex? Remember I said once you get it in the completed square form, the vertex is easy to get. All we need to do is to compute this part and equate it to 0, right? So x plus 4 all squared equals 0 implies that x plus 4 is equal to 0, and then if we have x plus 4 equals to 0, if we transfer the plus 4 to the right hand side, it becomes a negative 4, right? So the x value is what? Negative 4. And the y value, I say, what determines the y value? This. That means this was actually a perfect square that was resting on the y-axis, on the x-axis, sorry, and then it now undergoes a vertical translation by minus 7 units. Now let me show you the graph. Let us see how the graph of x squared plus 8x plus 9 actually looks like. Please, is the purple one. So we're going to look at x squared positive 8x, and the positive 9. So it's the purple one, please. So you can see, so easy. If you look carefully at the screen, starting from the origin, this is 0, this is 1, this is 2, this is 3, and this is 4, right? This is negative 4, right? So, and remember we said the vertex was negative 4, negative 7. Now, if we start from here to count, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Remember, this is a negative axis. This is a negative y-axis. This is a positive y-axis. So that's the vertex. Negative 4, negative 7. Quite easy. So let's continue. Question number 3. You can pause the video and attend this on your own, and then come back and cross-check as to whether you got it right or wrong. Question number 3 says, using completing the square method, calculate the coordinates of the vertex of the curve f of x equal to 3 plus 6x negative 2x squared, right? And the best thing to do here is to rearrange the function. Rearrange the function that has been given to you, because it's not that clear. Normally, a quadratic expression is of the form of ax squared plus bx plus c, and for me, it's best expressed like that. It's best rearranged that way. So the best thing for us to do, looking for that, remember we said f of x is equal to 3 negative 2x squared plus s6x. I rearranged it at this point. This is 3, remember, this is 3 plus 6x negative 2x squared, right? So this plus 6x negative 2x squared could be written as negative 2x squared plus 6x. Do you get that? Do you understand? So 3 negative 2x squared plus 6x, that's the rearrangement. So if you have 3 negative 2x squared plus 6x, because this is the same thing as negative 2x squared plus 3, right? So we now have negative 2x squared plus 3 plus 6x. But we know that addition is commutative. A plus b is the same thing as what? B plus a. So you could write f of x as negative 2x squared plus 6x plus 3. It's still the same thing. You can see what happened here. This is negative 2x squared. If we can make 6x negative 2x squared to be what? Negative 2x squared plus 6x. We now have negative 2x squared plus 6x plus 3. I hope you're on track. Please, if you've not subscribed to this video, to this channel, please ensure you do like and share. Hope you're enjoying the lesson. So f of x is negative 2x squared plus 6x plus 3. So we follow the same procedure. It's nothing different. So we take out negative 2, right? Negative 2. And then we can notice that negative 2x squared plus 6x has a common factor, which is negative 2. So we can take out negative 2, right? If you take out negative 2, that would be negative 2 bracket x squared negative 3x. Because negative 2 divided by negative 2x, that negative is going to cancel that negative, and we're going to have just x squared left. And then negative 2 divided by a positive 6x is going to give us a negative 3x. So basically, what we have is a negative 2 bracket x squared negative 3x plus 3. And now the next question is, this expression right here in this bracket, how do we express it in terms of a perfect square? What must be added to x squared negative 3x to give a perfect square? That's the first question. And what's that? You look at this, it's simply half of the coefficient of x. The coefficient of x in this case is negative 3. So half of negative 3 is going to give us a negative 3 over 2, as seen. And negative 3 over 2 all squared is going to give us what? 9 over 4. Why? Because negative times negative is going to give us a positive. And 3 squared is going to give us 9. And 2 squared is going to give us a 4. So negative 3 over 2 all squared is going to give us 9 over 4. That's nice. So if we continue with that, we're going to include 9 over 4 in this bracket. But remember, there is a change. Remember, our constant term is a positive 3. Right? Our constant term is a positive 3. So what do? We have included 9 over 4 here. And if we expand this, it's going to be negative 2 times positive 9 over 4. And if we should do negative 2 times a 9 over 4 times 9 over 4, what are we going to have? This 2 is going to go into itself as 1, and it's going to go into this as 2, right? So don't forget the negative. Then we have a negative 9 over 2, right? We have negative 9 over 2. So moving on with that, we can now write it in the completed square form. That's negative 2x negative 3 over 2, all squared, right? But remember, we have to respect this. There's a positive 3. It's negative 2x squared plus 6x plus 3. And you're expected to know that negative 9 over 2. Negative 9 over 2 is the same thing as 4.5 or 4.5. So if we have negative 4.5, we need an extra 7.5 because we have to retain the constant term. Negative 4.5 and a positive 7.5. If we add a positive 7.5, that's going to be 7.5 negative 4.5. And 7.5 minus 4.5 is going to give us a 3. Do you understand? All is about when you have brought out your terms, it just has to respect your f of x or your g of x or your h of x. So this is negative 4, negative 4.5. So you have negative 4.5, it's not enough. It has to respect this. We have already written it in this form. So we need extra what? 7.5. Right? Because negative 4.5 plus 7.5, which is the same thing as 7.5 negative 4.5, is going to give us 3. Right? So we'll now add 7.5. Now the question is, what is the vertex of the curve? What is the vertex of the curve? All we need to do, equate this part carrying the squared, which is what? X negative 3 over 2. Equate it to 0. right, equated to 0. This negative 3 over 2 will transfer to the right hand side and come over as what? A positive 3 over 2. And a positive 3 over 2 is the same thing as a positive 1.5. And then that's the x coordinate of the vertex. Then what's the y coordinate? Simply just what is that? The constant at this endpoint. This plus 7.5. So what's our vertex? 1.5, 7.5, or you could write it as 1.5 and 7.5. So please, I hope you understood all that I said in this teaching. Do well to subscribe, like, share if you've not. Thanks for watching. We'll see you again in our next playlist. Thanks for watching, and don't forget to subscribe, like, and share if you haven't. Thank you.